Hello everyone, this is Dhruv from Edureka and I welcome you all to this session where I will be talking about identity and access management in Google Cloud. So without any further ado, let's take a look at today's agenda. We will start this session by first understanding what is Google Cloud IAM. Then we will briefly understand its working and concepts. We will also look at how security can be strengthened through IAM service, and then finally we will then see a demo of demonstrating IAM service on Google Cloud Platform. Before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you are interested in online training certification in Google Cloud Platform, check out the link given in the description box below. First, let's understand what Google Cloud IAM is. So IAM, which means Identity and Access Management, lets you grant granular access to specific Google Cloud resources and helps prevent access to other resources. IAM lets you adopt the security principle of least privilege, which states that nobody should have more permission than they actually need. Let's now understand how Google Cloud IAM works. First, let's take a real-time example or say real-life scenario. Suppose if you enter a company and you got the visitor card, so you have a very limited access through it. Like you can access reception, you can access cafeteria, you can access a lobby where you can rest. Okay, now suppose you got selected in that company. Okay, you got selected as a fresher, as in the position of junior analyst, you can say. Now you have much more access than cafeteria, reception and lobby. Now you have access to certain databases, you have access to certain maybe cloud resources also, a little bit whatever is required for you for analysis purpose. Also you can have access to various analytical tools also, but you don't have complete access to all of them. Suppose now you are working under a senior research analyst. This senior research analyst, or you can say senior analyst, have much more access than you because you are a junior analyst. Senior analyst have much more access to more cloud resources. He has more access to much more Excel sheets also, you can say, and also like various other analytical tools also. Now suppose there's another person who isn't an analyst team. He's in cloud team, say he's a cloud engineer. So now you can see he might having the access of a lot of cloud resources compared to you, but he won't be having access to certain database services which you have access to, certain databases also which you have access to, a certain analytical tools also which you have access to. He might not be having that access. So that's how a certain rights and certain accesses are being provided to different teams and depending on their work. This is just, you can say it as a real time example. Okay, that's how access and identity management works. So now let's understand how IAM works in Google Cloud. With IAM, you manage access control by defining who means identity, has what access means role, for which resource. For example, compute engine virtual machine instances, Google Kubernetes engine clusters, and cloud storage buckets are all Google Cloud resources. The organizations, folders, and projects that you use to organize your resources are also resources. In IAM, permissions to access a resource isn't granted directly to the end user. Instead, permissions are grouped into roles, and roles are granted to authenticated members. An IAM policy defines and enforces what roles are granted to which members, and this policy is attached to a resource. When an authenticated member attempts to access a resource, IAM checks the resources policy to determine whether the action is permitted. You can see this following diagram illustrates permission management in IAM. This model for access management has three main parts. The first part is member. So a member can be a Google account, you can say for end users, and a service account, you can say for apps and virtual machines. And then there is a Google group or a Google workspace or cloud identity domain that can access a resource. The identity of a member is an email address associated with a user, service account, or Google group, or a domain name associated with Google workspace or cloud identity domains. Then there is a role. So a role is a collection of permissions. Permissions determine what operations are allowed on a resource. When you grant a role to a member, you grant all the permission that the role contains. Okay. And then there is policy. So the IAM policy is a collection of role bindings that bind one or more members to individual roles. When you want to define who has what type of access means role on a resource, create a policy and attach it to the resource. Now let's understand the concepts in IAM. First, let's understand the concepts related to identity. So in IAM, you grant access to members, and members can be of the following types. Like it can be a Google account, which represents a developer, an administrator, or any other permission who interacts with Google Cloud. Account can be an identity including gmail.com or other domains. New users can sign up for a Google account by going to the Google account sign up page. Then there is service account. A service account is an account for an application instead of an individual end user. When you run code that's hosted on Google Cloud, the code runs as the account you specify. You can create as many service accounts as needed to represent the different model components of your application. Okay. Then there is Google Group. So a Google Group is a named collection of Google accounts and service accounts. Okay. And every Google group has a unique email address that's associated with the group. You can find the email address that's associated with the Google group by clicking about. There is this option about on the home page of any Google group. Google Groups are a convenient way to apply an access policy to a collection of users. You can like grant an access controls for a whole group at once instead of granting or changing access controls one at a time for individual users or service accounts. You can also easily add and remove members from a Google group instead of updating an IAM policy to add or like remove users. Google Groups don't have login credentials, and you cannot use Google Groups to establish identity to make a request to access a resource. Then there is Google Workspace domain. Google Workspace domain represents a virtual group of all the Google accounts that have been created in an organization's Google Workspace account. Then Google Workspace domains like represent your organization's internet domain name, such as example.com. You can just for example. So I'm just naming it as example.com. And when you add a user to your Google Workspace domain, a new Google account is created for the user inside the virtual group, such as like you can take it as username at the rate example.com. Like Google Groups, Google Workspace domains cannot be used to establish identity, but they enable convenient permission management. Then the fifth one is Cloud Identity Domain. A Cloud Identity Domain is like Google Workspace domain because it represents a virtual group of all Google accounts in an organization. However, Cloud Identity Domain users don't have access to Google Workspace applications and features. Then the next one is all authenticated users. So the value all authenticated users is a spatial identifier that represents all service accounts and all users on the internet who have authenticated with a Google account. So this identifier includes accounts that aren't connected to a Google Workspace or Cloud Identity domain, such as personal Gmail accounts. Users who aren't authenticated, such as anonymous visitors, aren't included. And the last one is all users. So the value all users is a spatial identifier that represents anyone who is on the internet, including authenticated and unauthenticated users also. Now moving ahead to the concepts related to access management. When an authenticated member attempts to access a resource, IAM checks the resource's IAM policy to determine whether the action is allowed or not. So the first one in this is resource. If a user needs to access to a specific Google Cloud resource, you can grant the user a role for the resource. Some examples of resources are projects, compute engine instances, and cloud storage buckets. Some services support granting IAM permissions at a granularity finer than the project level. For example, you can grant the storage admin role to a user for a particular cloud storage bucket, or you can grant the compute instance admin role to a user for a specific compute engine instance. In other cases, you can grant IAM permissions at the project level. The permissions are then inherited by all resources within that project. For example, to grant access to all cloud storage buckets in a project, grant access to the project instead of each individual bucket. Or to grant access to all compute engine instances in a project, grant access to the project rather than each individual instance. And the next one is permissions. So permissions determine what operations are allowed on a resource. In the IAM world, permissions are represented in the form of service.resource.verb. For example, if you are using PubSub, then you can give it as pubsub.subscriptions.consume. That becomes service.resource.verb, right? Permissions often correspond one-to-one with REST API methods. That is, each Google Cloud Service has an associated set of permissions for each REST API method that it exposes. The caller of that method needs those permissions to call that method. For example, if you use PubSub and you need to call the topics.published method, you must have the PubSub topics published permission for that topic. You don't grant permissions to users directly. Instead, you identify roles that contain the appropriate permissions and then grant those roles to the user. So the third one is roles. A role is a collection of permissions. You cannot grant a permission to the user directly. Instead, you grant them a role. then when you grant a role to a user, you grant them all the permissions that the role contains. So there are several kinds of roles in IAM, like there are basic roles. Roles historically believe in the Google Cloud Console. These console are owner, editor, and viewer. Cautiously remember that basic roles include thousands of permissions across all Google Cloud services. In production environments, do not grant basic roles unless there is no alternative. Instead, grant the most limited predefined roles or custom roles that meet your needs. Then there are predefined roles, so roles that give finer grained access control than the basic roles. For example, the predefined role PubSub publisher provides access to only publish messages to a PubSub topic only. Then there are custom roles, so roles that you create or tailor permissions to the needs of your organization when predefined roles don't meet your needs. Like you can see here, an example of role is given, like the role is assigned as a compute.instance admin. Like the role is assigned compute.instance admin. So under this role, you have permissions to access all the resources under this role, like compute.instance.delete or like compute.instance.get. Everything is you can access. Now the next one is IAM policy. So you can grant roles to users by creating an IAM policy, which is a collection of statements that define who has what type of access. A policy is attached to a resource and is used to enforce access control whenever that resource is accessed, as you can see here. So an IAM policy is represented by the IAM policy object. An IAM policy object consists of list of role bindings. A role binding binds a list of members to a role. IAM provides a set of methods that you can use to create and manage access control policies on Google Cloud resources. These methods are exposed by the services that support IAM. For example, the IAM methods are exposed by the resource manager, PubSub, and Cloud Life Sciences APIs. Just to name a few, like the IAM methods are set IAM policy, which sets policies on your resources. Then there is get IAM policy, which gets a policy that was previously set. Then there is test IAM permissions that sets. Then there are test IAM permissions, which test whether the caller has the specified permissions for a resource or not. Now, moving on to the next and the last one, that is resource hierarchy. So, Google Cloud resources are organized hierarchically. Like the organization is the root node in the hierarchy. Then there are folders, which are children of the organization. Then projects are children of the organizations or of a folder. And the last one, like resources for each service, are descendants of projects. Each resource has exactly one parent. So this following diagram is an example of a Google Cloud resource hierarchy. You can set an IAM policy at any level in the resource hierarchy, the organization level, the folder level, the project level, or the resource level. Resources inherit the policies of all their parent resources. The effective policy for a resource is the union of policies set on that resource and the policies inherited from higher up in the hierarchy. This policy inheritance is transitive. In other words, like a resource inherit policies from the project, which inherit policies from folders, which inherit policies from the organization. Therefore, the organization level policies also apply to the resource level. For example, in this diagram, topic underscore A is a PubSub resource that lives under the project example prod. Suppose there is a account name Mika at that example.com, and if you grant the editor role to Mika at that example.com for resources for example production and grant the publisher role to song at that example.com for topic underscore A, you effectively grant the editor role for topic underscore A to Mika at that example.com and the publisher role to song at that example.com. The policies for child resources inherit from the policies for their parent resources. For example, if you grant the editor role to a user for a project and grant the viewer role to a same user for a child resource, then the user still has the editor role grant for the child resource. If you change the resource hierarchy, the policy inheritance changes as well. For example, moving a project into an organization causes the project to inherit from the organization's IAM policy. Now let's understand the practical actionable settings you can modify in the IAM, which will greatly improve the security of your project. So the first one is you can enforce multi-factor authentication. You can say it as MFA, which is a method where not only is one piece of information used to authenticate a user, example password, but there's also at least one additional source of proof needed to establish that the right person is accessing a system. On Google Cloud Platform, users authenticate themselves using Google accounts. These can be individual email addresses registered as a Google account or more commonly like accounts of a Google suite domain. On the Google Cloud Platform side, you cannot enforce that the Google accounts that have access to your project must have multi-factor authentication enabled, means MFA enabled. But if you only grant access to users from your Google suite domain, Then the Google Suite Domain Administrator can set up MFA on the Google Suite domain in a way that forces everyone to use it. If you need to give access to people without accounts in your Google Suite domain, then you can create accounts for them in your Google Suite domain for the sole purpose of accessing your project. This way you can enforce settings on their accounts. If you combine both these rules, then you can be certain that every user who has access to the Google Cloud Platform project needs to validate themselves using MFA, means multi-factor authentication. This makes it much harder to compromise your project even if the password for an email address leaks from another source. Second thing is you can set up password policy for users. The password policy settings are technically not inside the Google Cloud Platform, but at the discretion of the Google Suite Domain Administrator. If you only allow users from your domain and the domain is set up with the right password policy, then these two things combined will result in the password policy being enforced on all your Google Cloud Platform users. Third one is give the necessary but the least possible privileges. So it is a good practice in general to only give the minimum necessary privileges to all of your users. If all of the previously discussed account protection methods fail, your attackers will still have fewer services to break into or steal information from. The actual implementation of this principle will vary based on your usage patterns. For example, if your database administrators only need to do Google Cloud SQL administration tasks, don't give them project editor role, give them a Cloud SQL admin role instead. Also, what you can do is you can set up quotas. Like default quotas are set for every newly created project on Google Cloud Platform. This is a least resort security control to avoid unexpected runaway spending. For example, if you have a faulty script creating resources in a recursive manner, it will only be able to create them up to the quota limits. It can also protect against compromised account creating a lot of new resources for the attacker's purposes. The quotas can be changed on the quotas page, but it requires the service usage.quotas.update permission, which is only included in the following predefined roles like owner, editor, and quota administrator. So if a compromised account or faulty script does not have the permission, then the spending can only increase up to the quota limits. Last thing is check and rotate service account keys. There is another type of account on Google Cloud Platform besides the user accounts, that is service accounts. So service accounts are meant for programmatic use cases. They cannot be used to access the Google Cloud Console because they are only valid for Google Cloud API access. The most frequent use case is to run applications or instances inheriting the rights of a specific service account so they can access other cloud service without extra authentication. Service account use keys for authentication. One service account can have multiple keys associated with it. It is a good practice to regularly rotate the keys of the service account. This can be achieved by creating a new key for the service account, then overwriting the current key with the new one everywhere it was saved, and then deleting the old key associated with the service account. This way, even if an application where the key was stored is compromised without your knowledge, the attacker will only have a limited time window to use the key. Now that you have a theoretical understanding of Google Cloud Identity and Access Management working and concepts, let's now see a practical demonstration of it on Google Cloud Platform. So we are at Google Cloud Console now. This is how the dashboard of Google Cloud Platform looks like, means console looks like. You can see the ID dhruv.pandey@edureka.co. So what we are going to do is we are going to see the identity and access management. So let's move on to IAM and just click here and go to IAM and admin. And here you can see all the permissions the accounts have. So we are going to provide a new access to the, like you can also see the project here, it's demo billing. So from this project I will be giving the access. So let's add account, so you can add it from here. I'm going to add like the other account of mine in it. So yeah, it will be at project level. You are going to give a role now, so select it, go to project, give editor, as I have explained you how we have to give the editor role here, editor. Now you have to give another role at resource level. That's what is given in the policy, right? I have explained you the policy of access management. Choose a resource for it. So we are going to choose cloud storage. We can choose, so cloud storage, where it is. Yeah, so we are just going to choose the viewer option. Okay, so yeah, save it. But at the project level we have the editor option, remember that. Okay, so yeah, it's been added now. Now you can just go to, like, because you have the editor permissions at the project level, so you can just simply see how, like, we can go to virtual machine also. So here you can go and you can see if there is any virtual machine is there. Oh, just a second. Right now I am logging in the same account. So what I can do is I can go to another account that is which I have given permission to, right? So I'll go to this account. Sorry. So now I'm logged into my other account, that is roughpande2595@gmail.com. You can see now. So in this account, I have been to the VM instance now. So in this, you can see like there is no VM created now, but I can create an instance from here. And similarly, if you go to cloud storage, you can access other services also through this account because you have the editor option at project level. Okay, just go to cloud storage, and you can see there is this demo store cloud is here. So you can even create a new bucket, or you can just go to this one and you can upload any file into it also. Like I'll show you how upload files. Say okay, you can just upload this. So you can see how upload has been done because you have all the rights of editor. Okay, you can delete it also. So you just select this one. So you can just delete it from here. Yeah, action is permanent and it will get deleted. Now go back. You can even delete this one also. You can just select it and you can delete it from here. Okay, now let's move back to our own IAM permissions. This is the main account I am opening. You can see here. From here I will go to the IAM roles and everything. So IAM access management means identity and access management. And what I can do here is I can edit the roles. So what I can do is I can delete it from here. Like okay, I will not delete it at project level. No, I will delete it the editor. Okay, but the resource level it will remain, but it won't be completely be deleted. Okay, so I'm just deleting this one. So just select here, delete role one and save. Okay, now if you refresh it, you will see like you won't be having access to it. Now we have deleted the editor role. What we can do is we can choose the other account. Okay, now access to the secondary account, and then we will go to storage. Sorry, just a second. Cloud storage. So you can see the permissions are being limited, so you don't have sufficient permissions to view this. Even though the other way to view this is because you have the viewing option and don't not at the project level but at the resource level. So you can view it from the cloud shell. There are certain codes being given in the documentation part of identity and access management in Google Cloud. You can see the codes and you can just type it here at the command line interface of the Google Cloud. That is Cloud Shell, which is this. You can activate it from here and you can just access means so you can view the files from here. Okay, but not at the console. You can only be able to see it from command line interface, that is Cloud Shell. Now let's move back to this my main account. Now I can even delete these roles, like the roles I provided now. So I can delete this role completely. Okay, so I will just remove it from here, confirm. Okay, so that's how the role has been deleted. I hope you have understand how identity and access management in Google Cloud works. With this, we come to the end of today's session of identity and access management in Google Cloud. I hope you had a great time learning and understanding about it. And if you have any queries, please feel free to leave them down in the comment section below. Until next time, thank you.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!